Good morning to everybody. Thank you all for attending this joint webinar with Senstar and Blickfeld. Just before we continue, I wanted to make a short test in terms of technology. If the audio is coming through, it's when somebody would be able to put something in the chat to confirm it's running, that would be brilliant. Massive, guys, thank you very much. I would say let's give it a minute. So we have some people who are able to join as well. Based upon that, we kick it off, we take it away. So as said, I think we're going to start, and yeah, people who will join later can just join, and if they're not able to join, we will share the presentation afterwards, at least the recording instead. Again, a very warm welcome to everybody. Great to see so many participants on such a short notice, and in this case, a real short notice due to the rescheduling. Again, our sincere apologies for last time. The technique gave us a failure, unfortunately, but it wasn't that bad as we noticed last week, I would say, during an issue by a Windows update. Just a brief introduction. Who am I? My name is Stijn Bakkes, working for Senstar 1.5 years and responsible for business development across the EMEA region. Besides myself, thank you, Andreas, for pushing it ahead. We have Andreas Bollu in the call from Blickfeld in order to give you the presentation today. Great to see audio is running. What's on the menu today? Where you registered for to give you a glimpse about 3D LiDAR technology, new technology, and how you can use it, how you can utilize it in security measures, and how you can benefit and your customer can benefit out of that. Why, in many cases, we get questions, why is Senstar partnering up together with Blickfeld? In the end of the day, it's relatively simple. It's a new technology, and I think the majority of the attendees in the call do know Senstar already. Senstar has a quite wide range of perimeter intrusion solutions, which can be buried or can be mounted on a fence or on a wall. And to extend that, we worked with a partnership with Blickfeld, which we set up in May last year during the show in Birmingham. You see a nice picture over there. And we're really enthusiastic about the technique and the possibilities it can bring towards our customers. From that perspective, I think it's quite important to mention we're not only a selling partner, but we're also a technical partner, so we can help you in the total setup. We're focusing, from our perspective, on the EMEA region, and we are one of the main sales partners, technical partners in the region, which we are working with our way of going to market through distribution as you're used to. From this perspective on, I want to hand it over to Andreas from Blickfeld to introduce you to him and, of course, to the technique. So take it away, Andreas.
Thanks, Stijn. Good morning, everyone, and thank you for your attention. So maybe just to give you a quick overview about the agenda today, I'd like to start with an introduction of the technology and also myself and maybe the company Blickfeld. We'll go over basically why the 3D LiDAR now has advantages in the security field. We'll introduce the product, and the features, and the biggest focus will be the applications and the LiDAR in practice. So maybe a few words to us as a company. So we are a provider of 3D LiDAR sensors and software based in Munich, Germany. And we have multiple application areas where we bring our technology into, such as volume monitoring, security, crowd analytics, and mobility. Me personally, I lead the business unit for security at Blickfeld. We have a designated product portfolio for mostly perimeter security, consisting of the sensor itself and complementary mounts to bring the technology into the projects. Over the last 3 years, we're focusing on main industries to bring our technology into. One is military properties. This is basically where we started out. Aviation, so airports, hangars, fences. Another industry would be the energy, so power grids, power plants, industrial facilities, and in the end, even VIPs and private properties of high value. So maybe to give you a whole idea on why the 3D technology is now important in the security field. So here we're facing a couple of conditions of let's say challenges. So one is of course the weather. So weather, let's say changing lighting conditions, rain, fog, snow, wind, this all is a major cause of false alarms. Wildlife, so small animals trigger unwanted alarms. And of course, like shadows, day and night shifts, flashlights from cars, they can all cause, let's say, false alarms in the system. And if there's a large perimeter, these false alarms, they actually have a high cost for personal, but also financially. And in many cases, actually, this leads to a non-functional security system or a system with, let's say, yes, which proposes a security risk to the facilities. And of course, there are many approaches to do this. One is the 2D laser technology, which is also very reliable, but relies on rotating components that don't have any object size detection and no visual feedback. There's camera technology, so thermal, but also normal image-based cameras. So they're very intuitive and have a very high resolution and visual feedback. But yeah, no intrinsic data protection, no location information, no determination of the object size, of the true object size. And that's where the 3D LiDAR comes in. Here at this point, I want to say maybe a few points what this technology makes, stands out from this technology. So here on the left, what you see is like the pendant to a camera image. This is a point cloud. So each point that you see here is a point measured by a laser. So by a time of flight measurement of the laser beam. So let's say measuring the time of flight, so how long the light needs to travel to an object and back. And each of these dots that you see is such a measurement. And our system does around 500,000 of these measurements per second, each in a different angle, similar to a camera. And in the end, you get a 3D point cloud. So, and what you can see here, the advantages are clear. So you get a visual feedback and a clear localization of the object in 3D space. It's also possible to determine the object size independent of the distance, because you intrinsically measure the distance of an object. It's actually suitable for indoor and outdoor applications and doesn't need any additional lighting, because the laser itself does all the lighting. And it's also privacy protecting, as you can see here, because you measure the volume and the shape of a person, but not its identity. And this brings us now to the product, the Blickfeld QbProtect. It's a smart device, so all the processing happens basically on the device itself. Main feature is the MEMS mirror that we developed at Blickfeld. So there's no rotating component inside. We have a silicon chip that does the beam steering. This means the device has a camera-like robustness and also an IP67 rating. and it's a very small, has a very small form factor. We have all the processing on the device, so there's no need for an external computer, and everything can be configured through a web interface. And then we've also implemented, let's say, OnWeb and other camera interfaces, so that you have a very easy installation, just like a security camera, and also PoE power interface. Yes, so maybe these are things that often get asked: what area are we able to monitor? And it's something between 80 and 60 meters in the for, let's say, outdoor applications. And yeah, now maybe I've been talking a little bit about, or quite actually, I spent a lot of time on talking on an abstract level what the LiDAR is and what the LiDAR does. I actually want to make this a bit more practical and understandable. See, here on the right, you see a point cloud. So what I mentioned before, it's not like the stream, but if you had a camera, this would be the camera stream. But as this is a LiDAR, this is a 3D stream. And here you see in white, basically all the background points which are learned in by the system over time. This can be very fast. In about 30 seconds, the system can understand the scene. And then it determines all the moving objects. And what you see here is an object which is moving around, and by its size, it can be labeled as a medium-sized object, which means this is a normal person. And then we can trigger an alarm very reliably once this object moves into such a 3D dimensional zone. So the nice thing here is you can define as many zones as you want. The zones can have any shape. So basically they are cubic shapes, but you can put as many zones as you want. And these zones, they then depend on a certain threshold. So one is the object size, one might be the object direction, one could be the number of objects, and it's quite possible to exclude sources of false alarms. So as you can see, there are a lot of like vegetation in the background, but they can be excluded by precisely locating the zone just where you want it. So it can be placed also on top of the fence if it's necessary to only trigger an alarm in the case of overclimb. Yeah, small objects are basically excluded by very easily by their size. So yeah. And what I want to mention also is that it's possible to define here logical rules. So we have a very easy interface for this because many complex, let's say, objects require the triggering of zone 1 and then the zone 2. And here it's possible to basically combine different zones to get a more reliable detection. Right. So, and this brings us now to where the 3D LiDAR is used in practical applications. And the first application here I have is protection of, let's say, parked objects. In this case, it was a protection of, let's say, luxurious cars as part of a larger parking area. So this means we had cars that were parked in a larger area, which was actually accessible to the semi-public. So we had designated parking spaces for those luxurious cars, but we had movement of people around the cars, and this was also allowed. And the task here basically is to only trigger an alarm if we have the if you suspect a suspicious behavior close to the vehicles. And we also had always a different, let's say, configuration. So sometimes the cars were taken out and other cars might be returned in its place. And we had to adapt basically automatically to this situation. And here you can see now a video of, again, the 3D point cloud of this. You see the parked vehicles. You see also that we secure each parked vehicle with a precisely placed three-dimensional zone, and people are now able to walk around freely, and only a pre-alarm is triggered if a person gets close to one of the vehicles, and a secondary alarm is triggered if the person remains there for a suspiciously amount of time. And yeah, this fulfills actually this property very well. I want to mention that there are also many other cases which have similar requirements. So, for example, in the logistics field, oftentimes it is necessary to protect pallets, which are there parked like for a certain amount of time. And we should only, let's say, turn on the protection once the pallet is stored in a specific location. And we also want to contain, let's say, the alarming area to a very small part of the actual of the actually scene. So we want to localize, keep the alarm localized only there where the pallets are. And yes, so this application does not only work indoor. We've also have this in outdoor applications. So, for example, protecting parking aircrafts on the outside. This might be military jets, but also might be private jets. And the advantage with the 3D system is that we can learn in the type of the plane which is there, and then and this happens automatically, and then it gets protected. And it does not just get protected, let's say, two-dimensionally, but we are really protecting the aircraft from all three dimensions. And yeah, of course, it's weather independent. We have a day and night operations, and it's also suitable for high ceilings. So in case we have hangars, for example, or outdoor storage areas, might be for weapons, might be for pharmaceutical equipment. All this can be protected very precisely and three-dimensional. And the advantage here is that we really protect it from all sides, so there's no shadowing or anything else. And maybe what's interesting to mention is it is possible to really pinpoint the position of the object in three-dimensional space and transfer the geo coordinates to the customer system. So in case a PTZ camera, in case there's a PTZ camera to pinpoint the exact locations. All right. Now, maybe one of the biggest application of this technology is for fences. So only climbing over or crawling under, and then generally entering the side behind the fence. And it's possible to basically protect the whole perimeter with LiDAR sensors, or just place the sensors in critical locations where, because of camera angles or other things, it's very difficult to place a solution. And the advantage is that we have an object sized, like a detection based on the object size. So small animals can be excluded. High or cold temperatures can be excluded, and also anything coming with light, fog or rain basically can be excluded very reliably. You also have protection of privacy. So this might be an issue if you have a facility in the inside of a city where you don't want to, or where you're not allowed to use a camera, or if you have, let's say, a working environment and you need to protect the privacy of the workers. In this case, it makes a lot of sense to have a let's say, this privacy protected solution. And it is also possible to have a very reliable early detection zone. So to draw a pre-alarm zone to identify threats and intrusions. And there we have two possible mounting, let's say, variants. One is just having a single sensor mount, which can then cover up to, let's say, 60 meters reliably, or let's say a pole distance of something like 60 meters with different alarm zones, let's say an overclimb zone and maybe a main alarm zone once the object has entered the area. And the same thing is also possible with a dual sensor mount. Because the sensor has a 90-degree field of view, it's possible to mount two sensors back to back and cover something like 120 meters with just one mounting position. And how this looks like, here is an example of a real application protecting the area here on the left. As you can see, there is, let's say, a part of open area on the left with also high grass. On the right, you have a public pavement. And yeah, basically by mounting the LiDAR here on a pole, it is possible to define these two zones, as you can see here. One zone is an overclimb zone, which triggers as soon as an object enters in the zone above the fence. This has a very high threshold to trigger here really fast. And then there's another zone placed over the area of the grass here, which basically tracks and detects intrusions into this area. All of this can also be displayed in let's say a Google Maps view live in the web GUI of the device. So if there's a large facility, it's easy to say georeference and get an understanding basically where we are placing the sensors. And this is how this looks like in again, let's say the three-dimensional view of the LiDAR device. Here we see the person walking around and yeah, basically climbing over the fence, and we basically trigger only in the event of the intrusion. All of this is really privacy protecting. What's happening basically behind the zone does not really matter because we are able to place three-dimensional zones and then only trigger in events of a real intrusion. Right. This stream here is also available through an ONWIF interface, so it can be used for verification in case someone wants to understand why or where or what was triggering the alarm. This information is also available. And the big advantage is that, yeah, you pretty much get always the same view, independent if it's day or night. And it's very clear to identify where the intrusion happens. So, and this was the fence. Another interesting application is a bit more complex. These are securing gates, locks, or entrances, where we usually have a bit more of a complex situation. We have sometimes a mix of, like, let's say, a personal or like an entrance for personal, and we have an entrance for vehicles, and both needs to be protected. And here we see a very concrete example on how we did this in a use case. On the right is the entrance for people, where it's allowed to enter through the gate, but it's not allowed to climb over. And on the left, we have the entrance for vehicles, where we don't want to allow people entering or leaving through the vehicle exit or entry. And yeah, this is basically also the video how this then really looks in reality. As soon as a person tries to climb over here, this creates an alarm. And as soon as a person tries to walk through the vehicle gate, either by climbing over or by crawling over, this also triggers an alarm immediately. It can be disactivated if a vehicle basically opens the gate for this amount of time. The vehicle zones are basically disactivated, but the overclimb zone on top of the gate is always active. All right. So I think this was a quick overview from my side into the application areas of the LiDAR. And I hand over back to Steve Stein.
Thank you very much, Andreas. I think massive job. Just a takeaway, or at least a few key benefits, I would say, by using LiDAR technology or adding LiDAR technology to your solution for your customers or from an end user perspective. When you talk about weather, snow, fog, rain, hail, it doesn't impact the quality of the image. When you talk about day or night, you always have a clear vision. And I think a massive key driver is the 3D technology. First of all, you can position different views or different angles. But secondly, you're able to measure an object and the size of that. And when I'm correct, and now I need to look virtually to Andreas, in terms of accuracy, we can go up to 5 to 10 centimeters. Am I right, Andreas?
Yes,
More or
10
less?
centimeters.
Just to give you an impression how accurate the system can work when we talk about detecting something. Another massive benefit when you look to the, I would say, technology which is commonly used is when you're able to measure on 3D distance an object, you can exactly determine if it's in front of a fence or behind a fence. So when do you want an alarm? In many cases, depending on how you program or project your cameras, it's quite hard to determine that. So nuisance alarms, which is a massive thing in perimeter intrusion, we're able to bring this back with this new technology. On the other hand, I think it can work together with cameras in a good way, so you can mix and match the solution in a proper to get to the best solution for your customer. Besides perimeter intrusion, the majority of you will know that we also do video management with Symphony. And like Andreas already mentioned, OnViv is a key driver into when we talk about integrating in different VMSs, and in this case into Symphony. Where you're able to push it one slide further, perfect. It's an easy integration because it handles itself as a camera. The way how we do it is quite simple. You connect it towards your network. Based upon that, you run a search in Symphony, and it will be detected and seen as a camera driver based upon OnViv. Based upon that, you get the metadata, so you get the alarms you get in, and of course you get a view in. If you click to the second part of the slide, Andreas, if you want, perfect. You're able to set up zones or alarm zones, as Andreas mentioned already, in the web GUI, in the 3D LiDAR. These are also the topics we're getting in, and based upon that, we're able to determine in our Symphony software to see where we need to pop up or when we need to program additional actions or additional rules. Meaning, when we get an alarm in a certain zone and we also want to identify a specific person, we are able to pick up with the PTZ camera the person or at least the alarm in question, which can benefit from that perspective, or other rules which you can trigger based upon that. When we talk about the installation of the LiDAR itself or commissioning the LiDAR, it's relatively easy. It's like a camera. In this case, you would do with a laptop. You can do a stream check with the web interfaces running. You can program the zones, and based upon that, you can connect it towards your VMS. Now we're talking about Symphony VMS, but as we talked about OnViv, I would say even every respectable video management system is able to support this from that perspective, which is good. If you push it through to the next slide, Andreas, perfect. Of course, if you want to see us, please stay informed. We have the security show in Essen coming up. We are there at Hall 8, so happy to see you over there. And I want to highlight again, in terms of availability, the product is available through us and also through our regular distribution partners. So in case there are any questions, feel free to reach out to Andreas or myself in order to support you. We have even some LiDARs available for some testing setup, so please get in touch with us. And when there are any questions, we're happy to support you. Any things we forgot, Andreas, which we need to cover?
No, I think we're good.
Thank you. Thank you for all the attendees. Let me have a brief look to the questions we are facing. I see one question is popping in. With regards to small objects, using birds as an example, how can the detector mitigate for birds on the perimeter wall when there are several birds together which create a large object? Is that anything you can address, Andreas?
Yes, I can.
Classify the objects?
So yes, we basically clustering the objects, right? So if you have multiple birds, you get also multiple objects. Of course, if you're unlucky and you get, let's say, a huge bunch of birds in one very small condensed area. This might trigger your alarm. This is true, but to be honest, we never had really problems with birds, and we were actually, let's say, we had many facilities inside of cities where there were problems with pigeons and things like this. We actually saw very good results by using our technology there.
Sounds good. Thank you very much for addressing the question. When there are other questions which we'll probably raise after you've seen this presentation or this webinar, please feel free to reach out to us. Happy to support you on that. And based upon that, we're going to close the webinar. I want to thank you all and wish you, as they would say, a happy Friday or at least a good weekend in advance. Thank you very much, all.
Perfect. Thank you, guys.
Cheers. Bye-bye.